Today we're going to be talking about the idea of absorbing and emitting energy. So let's write those words first. Well, that would be helpful if I started with the right letter. Absorbing and emitting energy. And as I always like to do, I'm going to start off with an analogy, okay, to help us sort of get an intuitive understanding of what these two words mean for us in this class. So let me start off by drawing a staircase, a set of stairs. So imagine that we had let's say a bowling ball. I'm going to make it green because why not? So here's my bowling ball, big heavy bowling ball. Here are the little finger hole things. And let's imagine that I pick up this bowling ball and I lift it up and set it on the top step. All right. It takes energy for me to do that, right? I need to actually put energy into the ball. I need to lift it up and imagine doing that. Imagine what that feels like. It takes energy to do that. So let's write this down. We can write, it takes energy to lift a bowling ball upstairs. Okay? It takes energy. Now, what takes energy? Or actually, in this class, I want you to think about from the perspective of the ball is taking that energy, right? And what we're going to say in this class is this. We say the bowling ball absorbed this energy. Absorbed energy. So the bowling ball moving up to the top step or up the step is the bowling ball absorbing energy. And I've gotten the question from a couple of people, but why does it absorb energy? So what I want to clarify is I'm telling you what this word means by this example, right? So what I'm saying is this action of the bowling ball going up the steps, we're going to call this absorbing energy. Okay, and hopefully it makes a little bit of intuitive sense. That's my hope with this analogy. So let's look at another analogy. Let me just copy and paste these stairs. And if you are taking notes from this, you should be drawing the stairs, right? So you might have to pause the video for a moment. Let's say now that we have our bowling ball again, but this time we're going to put it here at the top of our stairs. Okay, so here it is on the top step. And this time we're going to say that it falls down. Okay, and really let me just draw this like it's going to fall down onto this bottom step or onto the floor, on the ground. Okay, so what we're going to say is when a bowling ball falls down stairs, it releases energy. And one thing I want you to think about is what if your phone, what if your phone was right down here, right where the bowling ball fell? How happy would you be about that situation? Probably not very happy at all, right? Because all that energy that it released would go into smashing your phone. So I'm just going to put imagine if it fell on your phone. If this causes you pain to think about, you should thank me because I actually originally was going to do this analogy using a phone, but then I thought I was going to say like imagine a phone being dropped down the stairs, but I thought the bowling ball was a little bit more dramatic. So you don't have to experience so much pain as you might have, right? So the bowling ball here releases energy when it falls. It releases that energy, and so we say the bowling ball emitted energy. Now, I will point out that in real life, we don't usually talk about bowling ball energy being emitted, right? We talk about, it's smashing things or, maybe words more like that. But I want you to get comfortable with the idea that a bowling ball falling down to a lower step is how the bowling ball emits energy, right? It emits energy. In this example, it's emitting energy by smashing the phone, right? But in general, when things fall, they emit energy. Okay. So let me, you might have to pause to finish writing this down. I'm going to clear most of this here. Let me clear that and this. All I want now is my staircase, just one staircase for now. So let me pull this staircase over here for a moment. And next, I'd like you to write down this. We can represent something absorbing or emitting energy using an energy level diagram. So this is a new word, okay? And I'm going to show you what an energy level diagram is, but let me underline this, an energy level diagram. We're going to learn what that is. So let me make an energy level diagram. For this, I'm actually going to use my line tool. What we're going to do for our energy level diagram is imagine that we're just extending the stairs. Oh, it would help if my stairs were not white. I'm sorry, if my lines were not white, because if they're white, you probably can't see them. Let's see if this works now. Did that work? Also not. Sorry. Hold on. Let's see if I can make my stairs. Let's see if I can make my lines black. Come on, the color black. Come on, the color black. Let's try it again. Let's see how many times it'll take Adriana to draw a black line. Oh, there it is. It's just really, really thin. Maybe I just need to draw this instead of trying to do it this way, but give me one more moment. Let's see if I can make a thicker line. Okay, that looks better. That's not too bad. It didn't take so many tries. Okay, let me just copy and paste these instead of trying to draw lines over and over, since apparently that's not going very well for me. So here's another line. I'm extending my steps here. Let me actually line it up with my step. One more. Okay. Here are my steps, and they should all be the same size. It doesn't really matter, but I'm kind of weird about it, so I'm going to take my time to make them the same size. Okay, so here's my energy level diagram. Now let me label a few things for us that we're sort of seeing for the first time in this way, but we've seen it before, and I'll show you why. I'm going to label this bottom line n equals 1. Now, what does that mean? It literally just means, all that is telling you is that this is the first, I'm going to call it an energy level. See how I did that there? Energy. The N, that's how you can sort of remember what that means. It's just telling you your energy level, right? And actually, the first energy level, we're going to give it a special name because we're talking about just one ball. We're going to start using this idea of what is called a ground state, okay? Ground state. Now, it's not always quite so simple as just saying, oh, it's the bottom one. But in this case, we're just going to start thinking that the ground state is when everything is in the lowest energy level that it can be, okay? So I just want to introduce that word as the idea that it's in the lowest possible energy level. And so our next line just represents our second energy level, and the next line represents our third energy level, and the next line that represents our fourth energy level. Hopefully all of this sort of makes sense to you. And so what we can do is we can represent things moving between these energy levels, kind of how we did with our bowling ball. But this time I'm going to draw my bowling ball right here. I'm just going to draw it as a circle this time. And this is me showing you that the bowling ball is on the fourth energy level. Okay. And I can draw an arrow going down to the first energy level. This picture right here is exactly the same as if I had drawn my picture of my ball falling down to my first energy level. Okay? Hopefully you can see that these two pictures are the same, but now I'm showing it to you in an energy level diagram, but it's representing the same idea. So now let me draw, let's do another example. Oh, you don't even have to draw the ball. So you could draw just an arrow going from the fourth energy level to the first energy level. So from the fourth to the first, these are exactly the same thing. You don't have to draw the ball, but you can, okay? And you don't have to always go down to the first step. It is possible for the bowling ball to just fall down. Whoops, let me not do that. Hello? Hold on. I know how to fix this. There we go. It is possible for my bowling ball to fall down to just, I don't know, the next step, right? I could just do this. So in that case, I would just draw an arrow going from the fourth energy level to the third energy level. All right, so that is the same idea. The only thing you can't do is this should make sense to you. Imagine it's not possible for me to say, what if the ball fell down halfway between the step and just stayed floating there? It can't do that, right? So you're never going to have an arrow that's whoop, it's just part way down there. No, that doesn't happen. That's impossible. It needs to be on one of the energy levels, just like our bowling ball needs to be on one of the steps. It does not float in between. So that idea should actually make some sense to us. So these three, I want you to think for a second, are these three arrows showing me examples of absorbing energy or emitting energy? Hopefully you were able to see that these are all falling examples. And so these are examples of emitting energy, right? And so let's do some examples then of absorbing. How could we draw that on our energy level diagram? Well, we could draw a ball on the second energy level, for example, and draw an arrow up to the fourth, right? So that's one thing. You could also just do it without the ball. You could say, what if I had a ball that went from the first energy level up to the fourth energy level? That's also okay. Maybe you just have a ball that goes from the second energy level to the third energy level. That's also fine. These are three examples that are all showing examples of absorbing energy. Absorbing. All right. So hopefully all of this is making some sense to you. All right. You need to be comfortable with seeing and writing these. So let me go ahead and pause the video if you need to finish writing something. I'm going to go ahead and delete most of this again. Let's see. I think actually maybe I'll leave that part of my diagram for now. I think I'm going to get rid of my ball finally. I'll miss you. You were fun. Let me take these and move them over for now because we're going to need them for something else in a moment. And I'll just get rid of my arrows and things because now what I'm going to do is show you how this relates to what we've been learning, because maybe you're thinking to yourself, okay, that's all fine. What in the world does this have to do with anything that we've been doing so far? So let me try and show you that now. I'll need to shorten my lines a bit. Let me shorten my lines a bit here. So what I want you to think about now is another idea. So let me give us a new header now. And our new header is going to be this concept. Electrons, and we've been talking a lot about electrons. Electrons absorb and emit light. Electrons absorb and emit light. So think about this. If an electron absorbs enough energy, and this can be light energy, this can actually be other kinds of energy too, like heat energy, electricity, and more, right? It could be any kind of energy. Whoops, let me actually write electricity, right? So if an electron absorbs enough energy, it can jump to a higher energy level. So let's look at our simplest example that we can do. Let's do an example of hydrogen, because hydrogen is our simple atom. It's just has one little electron, right? And so this will be a good one for us to start with. And let me see if I can make this sort of easy for us to see. Let me give this circle a little more weight so we can actually see it. Okay, so here's one energy level. Bear with me for a second while I make this picture for us. Here is going to be our next one, but let's actually stretch this out to about there and center it there. And let's do an even bigger one of those. Hopefully you can kind of see where we're going. If not, you will in a moment. So hang with me for a second while I finish drawing this, or whatever you call this digital artistry kind of thing. So there's that one. Maybe I'll center it a little bit more. And let's make one more. I'm wondering if you all have seen now what I'm doing. Oops, that's not what I wanted. Let's try that again. Okay, hopefully that looks pretty good. I'll take it. So what I want you to see is that now this inner ring right here represents my first energy level, right? So just like we had before with our steps and our energy level diagram, this line right here now represents my first energy level. The next ring represents my second energy level. The next ring represents my third energy level. And finally, the outer ring represents my fourth energy level, right? And I've already said that we're trying to represent the element hydrogen right now. Now you might be thinking to yourself, this is not right, because hydrogen, if we look at our valence electron configuration chart that we've been looking at all this time, right? Let me just put it over here. Hydrogen only has one energy level, right? And in fact, it only has one electron. All this time when we draw our Bohr models, we have not been drawing hydrogen with more than one energy level, right? So what I'm telling you here, though, is that even though you're right, you would not draw a Bohr model with an electron beyond the first energy level, it is possible for an electron in that first energy level, that one electron that hydrogen has, it actually might absorb some light, some energy, and I'm going to sort of represent that with this. We're going to say this is maybe some ultraviolet radiation. And when it absorbs that energy, it actually forces that electron to jump into a higher energy level. Let's just say that it jumps up to the fourth energy level. Okay? So let's write about this. So right here, what is this representing? This is a photon. So we can say a photon with enough energy forces the electron into an unstable, excited state. All right, the electron absorbs the energy, right? It's going into higher energy levels, and now we're in an unstable, excited state. The electron does not want to be up here, right? Do you remember how we've talked a lot about how you can't make a cake with layers and just put a third layer on, right? You cannot have a floating layer of cake above nothing. Well, this electron is not comfortable, right? It is not low energy, or it is not comfortable for this electron to be way up here with nothing else filling in the inner layers. Usually the only reason electrons are in the outer layers is because there's just no more space on the lower energy levels, right? We've seen that with our periodic table. The only time that we put electrons into higher energy levels is because we ran out of space on the lower ones. That's the only time. So let me move this whole thing up a tiny bit, because now I want to look at what happens if we're in an unstable state. Things will not just stay like this, right? Because it's unstable. So let me copy this. Let me copy this here. Actually, I don't even need that light here. Okay, I don't know what all I've grabbed. Let's see what copy and pastes here. Oh, okay, it's okay. This is what I wanted. So here's the new situation. Now my electron is no longer there, right? As we said in the previous picture, it jumped up to a higher energy level. I'm just going to put it here because why not? It jumped up into a higher energy level, right? So now it's way up here. This is not stable. It's not stable. And so what's going to happen is it's actually going to fall. It's going to fall. Now, this idea of falling is kind of weird when we're thinking about electrons, but that's exactly what happens. Just like our bowling ball fell from the higher step to the lower step, now our electron is going to fall from a higher energy level back down to a lower energy level. And just so you know, it doesn't always have to fall all the way back down here in one go. Sometimes it might fall here first, and then later it might fall down again. But in this case, let's say it falls all the way back down in one go. Well, what do you think is going to happen? Think about, what do we call it? What do we call it? Look at our words. Look at the title that we're working on here. This is an example. Let's write this here to make it a little bit easier to explain what I'm asking. This is an example of an electron absorbing. I said it was ultraviolet, right? So let's just put UV light. This is my example here, right? What is this going to be an example of? It's not absorbing energy because it's falling, right? This is going to be an electron emitting energy, right? But what is it going to emit? Think about that for a minute. When it absorbed this UV radiation, this UV photon, it jumped up to the fourth energy level. Now it falls back down to where it was before. What do you think it's going to emit? It's actually going to emit that same exact photon. I'm going to put UV light here. And really, it's emitting the same photon. It's emitting a photon with exactly the same energy. All right. And so this is what happens when an electron falls. So let me write that. So here we are going to write when an electron falls back to a lower energy level. When an electron falls back to a lower energy level, it emits energy in the form of a photon. All right. So this is the concept that we're going to be looking at for a little while, getting some practice with. In the next video, we'll look at a specific example. We'll be looking specifically at what kinds of electron transitions hydrogen experiences. So we already just looked right now at an example of hydrogen absorbing and emitting UV light, but there's actually more to the story. There are more things that can happen with a hydrogen atom, and so that's where we're going next.